Hi there, and welcome to my Redhead Professor YouTube channel. And in this mini lesson, we're going to go over time value tables. And this one specifically is going to be the future value timetables, which there's a couple different time value tables, and I think the future value table is the easiest to understand and get a handle on. Once you can feel confident in this one, you can move on to the other ones. But this one is just really easy to start with and get the understanding and the application of the concept of time value tables down. So to start off with, let's kind of go over what a time value table is. It looks like, honestly, just a bunch of numbers that are really neatly laid out, but there's a little bit more to it than just neat rows of numbers. Along the top, you have the rate or the percentage of interest that you earn. It's along the top, and it's usually, sometimes they go in half percents. You could even go down to 0.1% if you really wanted to, but usually they keep it in whole percents or whole and a half, like 1.5%, just because your spreadsheet gets quite large. But just for a basic table, it's usually whole percents along the top, and then along the side here, they have the time period. So 1 year, 1 time period, 2 years, 2 time periods, 3 years, 3 time periods. Pretty simple, pretty basic. Now, let's go back to that one. Now, the reason that these time value tables, specifically this future value timetable, becomes just such a neat tool to use is it saves a bunch of time. And the reason it saves a bunch of time is you can calculate something that is going to, like for instance, I have it set up here, $1 that we're earning 3% interest on it, and we're going to leave it in the savings account for 3 years. So you can calculate it out the long way, which is principal times rate times time equals the interest. Then we have to add the principal back in, and we get our maturity value, and that calculates 1 year. So 1 year for $1, so $1 in a bank earning 3% interest for 1 year earns us 3 cents. Then we add the principal back in, so we get 3 cents in interest, $1 in principal. We end up with a maturity value of $1.03 that we can turn around and leave in the account and have $1.03, earn 3% on it again the second year, times that 1 year that we're leaving it in there at this $1.03, and we're going to earn 3 1/10 cents. So then we add that to our principal, $1.03 plus that 3 1/10 cents, and we end up with a whopping $1.06 1/10 cents. And then we can take that to the third year and take that maturity value, multiply it again by 3% times 1 year, and we end up that now we're earning 3 cents, 3 2/10 cents. And add that to the principal, and we're at $1.09 3/10 cents. So that took three multiplications, about a couple different additions in there to come up with just what $1 at 3% interest saved for 3 years or 3 time periods would give us. There's a much easier way, and that's where these timetables come in. You could have taken that 3% and intersected it with 3 time periods and taken 1.093 and multiplied it by your principal, your original principal of 1, and you would have skipped the end down here. That's 1.093. So that would have taken just a few seconds of going, okay, 3% and 3 time periods gives me this number, multiply this number times my principal, and voila, I have my answer. Really quick and very clean. And that's how these timetables were calculated or are calculated. They take $1 and they multiply it by either 1%, 2%, 3%, 4%, or whatever you've got along the top here as far as your interest rates. And then they multiply it by how many periods you've had it invested, and you end up with these factors down here that they give you. So, oops, keep hitting that. So once you have this factor, it's calculated based on $1. So you can impose it on any amount of money. So say this was $20,000 that I was going to save. So I could just put $20,000, and if I'm saving it for 3% for 3 years, if if it works for $1, it would work for $20,001. So 20,000 times this amount that $1 would be, 1.093, then I end up with my answer. So it really cuts a lot of the repetitive work out of it. I mean, it's sometimes, this is the accounting geek in me coming out, but it's kind of relaxing to just sit there and add and multiply numbers. But if you just really want a number and you want it fast, this is the best way to do it, and it's very accurate. So the type of questions that it answers, because there's a specific set of questions, there's some characteristics to questions that it can answer. It has to have one rate. You can't have a problem that says, okay, it's going to be 3%, then it's going to be 4%, then it's going to be 5%. It has to be one rate for the time period of the question. It also needs to be one lump, just one, for future values. There's two different future value tables, so don't get them confused. There's one that's future value of $1. That's one lump. Or there's future values of an annuity or a series, depending on what table you're looking at, how it's labeled. But this future value of $1 or one lump, you're dealing with one lump of money. So you're not dealing with, I'm going to save $1,000 every year for the next 20 years. Oops, and my battery's going dead. All right, I guess I'll hurry up. The next one, characteristic that it has to have is it has to be in the future. So we're not working backwards, we are working into the future. So if I save this today, what will I have in the future? Not what would I have to have saved in the past to have it now. We're looking towards the future for all of these. All of these questions have to be forward future questions. It seems kind of simple and like, why would you mention that? But when you start getting into these problems, you understand what I mean by it has to be a future. That has to be a characteristic of it. So, some examples of questions that it would answer. If you purchase a house for $120,000 and real estate in your area is expected to increase in value by 2% each year, how much do you think your house would be worth in 5 years? Okay, so we have our one rate, our time periods, and one lump. Second one, if I need $75,000 to cover all my living expenses and prices are rising by 1% each year, how much do I need to live in 4 years at the same level? So I still want to live at my $75,000 lifestyle, but prices are increasing by 1% each year. So how much do I need to have? So it has our rate, the rate isn't changing, and our periods, and our one lump. This is an example of another one. How much will I have in my savings account in 3 years if I deposit $2,000 at 4%? So the rate hasn't changed. It's one lump. It's not I'm depositing $2,000 each year. It's just $2,000 deposited one time. So let's try it out. Back to that first example problem. If you purchase a house for $120,000 and real estate is expected to increase in value by 2% each year, how much would your house be worth in 5 years? So, two things we're looking for. We're looking for our rate, and we're looking for our period. So we can take it and look at it in this chart. So in this case, our rate was 2%. Our period is 5 years. So we're going to want to take that information, and we're going to want to go over to our chart here and go down, find the 2%, and take it down and intersect it with 5 periods. So at the intersection of 2% and 5 periods, we get the factor of 1.104. So that factor of 1.104, we're going to take it and multiply that factor times the principal, which was at 120,000, and that's going to give us our future value. So 1.104 times 120,000 gives us $132,480. So that's how much our house is going to be worth if prices continue to rise at 2% each year for the next 5 years. The next one we're going to look at was if I need $75,000 to cover all my living expenses and prices are rising by 1% each year, how much do I need to live in 4 years at the same level? So we're looking for our two pieces of information that we need to go to our time value chart. We need 1%, the rate, and we need the time periods. So 1% is the rate. The period was 4 years. So we take and intersect 1% and 4 years, and we come up with a factor of 1.041. And then we take our factor and multiply it by the principal, and that's going to give us the future value. So in this case, 1.041 times 75,000 means we're going to have $78,075 in 4 years. If prices keep rising at 1%, that's what we're going to need to live. And the third one, how much will I have in my savings account in 3 years if I deposit $2,000 and earn 4%? So we're looking for those two pieces of information, the rate and the period. The rate in this one is 4%, the period was 3 years, and we just intersect them. 4%, 3 years, and we get a factor of 1.125. Take that factor, multiply it by the principal, in this case was $2,000. 1.125 times 2,000 is going to give us $2,225, excuse me, $2,250 at the end of that savings period. So anyway, really neat tool. Hope you enjoy learning how to use it and that this lesson was helpful. See you again next time.